Today, electricity is so common that we barely notice it. We switch on a light, charge a phone, turn on a television, and expect everything to work. But imagine a world where nobody understood electricity at all. No batteries, no power stations, no electric lights, just a mysterious force that appeared as sparks, shocks, and lightning. Long before scientists understood electricity, humans had already witnessed its power. Lightning could tear across the sky. Sparks could appear from certain materials, and sometimes objects seemed to move without anyone touching them. One of the oldest recorded clues involved something surprisingly simple: amber. Ancient Greek observers noticed that when amber was rubbed, it could attract small pieces of material. An invisible force seemed to appear from nowhere. There was no visible rope pulling the objects, no magnet could explain what they were seeing. It was simply an invisible effect. For centuries, electricity remained a strange curiosity rather than a technology. Eventually, curiosity became experimentation. Scientists began creating machines that could deliberately produce static electricity. They could now create sparks whenever they wanted instead of waiting for nature to provide them. These experiments were sometimes frightening. A scientist could build up a charge and suddenly receive a painful shock. But every shock revealed something new. Electricity could be produced, transferred, and observed. Then came a breakthrough: the Leyden jar. It allowed scientists to store electrical charge and release it later. For the first time, electricity could be collected and kept ready for an experiment. Across the Atlantic, Benjamin Franklin became fascinated by these experiments. He wanted to understand electricity, but he also had a much bigger question. Could the mysterious electricity produced in laboratories be the same force responsible for lightning? In 1752, Franklin carried out the experiment that would become legendary. During a thunderstorm, a kite was raised with a conductive arrangement attached to its string. Franklin wasn't trying to catch a lightning bolt. He was looking for electrical charge in the storm. The experiment supported Franklin's theory. Lightning and the electricity produced in laboratories were connected. The sky itself was electrical. A force that had once seemed supernatural was becoming something science could investigate. But scientists still faced a major problem. Static electricity could create impressive sparks, but it was difficult to produce a continuous flow of current. To make electricity truly useful, they needed a new way to generate it. Then in Italy, a strange observation changed the direction of electrical science. Luigi Galvani was experimenting with frog specimens when he noticed something remarkable. Under certain conditions, the frog's legs suddenly twitched. Galvani believed he had discovered a form of electricity inside living animals. He called it animal electricity, but another scientist was not convinced. Alessandro Volta believed the electricity might come from the interaction between different metals. Instead of simply arguing about it, he decided to build an experiment that could test the idea. Volta stacked alternating layers of different metals with material between them. In 1800, he announced his voltaic pile. Unlike the sudden discharge of a Leyden jar, the new device could provide a continuous electrical current. This changed the scientific world. Electricity was no longer only a sudden spark or shock. Scientists could now produce a steady current and send it through wires. A new era had begun. The new batteries opened possibilities nobody had seen before. Humphrey Davy used powerful electrical currents to create an intense arc of light. Electricity was beginning to reveal another secret. It could produce artificial light. But one of the most important discoveries was still ahead. Michael Faraday, who had started as a laboratory assistant, became fascinated by the relationship between electricity and magnetism. In 1831, Faraday discovered electromagnetic induction. He found that changing magnetic conditions around a coil could produce an electrical current. It was a simple idea with enormous consequences. Faraday had uncovered a principle that could turn mechanical motion into electricity. Instead of depending only on chemical batteries, machines could generate electrical power from movement. From there, the possibilities grew rapidly. Electricity moved from scientific laboratories into communication, lighting, industry, and eventually homes. What began as a mysterious attraction between amber and tiny pieces of material was becoming the foundation of a modern world. So, who discovered electricity? There isn't one simple answer. Ancient observers noticed its effects. Scientists learned to create static charge. Franklin connected lightning with electricity. Galvani and Volta changed our understanding of electrical currents, and Faraday showed how motion and magnetism could generate electricity. The electricity flowing through your home today is the result of centuries of questions, experiments, failures, and breakthroughs. No single person created the story. Generation after generation added another piece to the puzzle. And perhaps that's the most fascinating part. Electricity was always around us. What changed was humanity's ability to understand it.